Okay, so the next thing we want to do is um, see what happens when we rig, or skin rather, the biceps to our rig. So I'm going to click on biceps, and I'm going to click on the scapula, which is I'm sorry, I want to say the biceps surface. Hold the command key or control key on a Windows machine and click scapula, which is now the top joint in the hierarchy here. And under skin, I'm going to say bind skin. And if you remember, I'm using joint hierarchy here. So I'm letting the software automatically associate different joints with vertices according to their location or how close they are. So theoretically, this collection of vertices should be heavily influenced by these two joints because they're close to it. So we'll say bind skin, and let's play our movie. And you can see let's go and make this big. When we scrub this, you can see the muscle does move. It stays with the bone. The two heads, the two insertions, if you will, or I'm sorry, the two origins, do stay anchored. They move a little bit, but it's just okay because I think it would be a little unnatural if they were too stiff. But the problem we predicted does happen when we flex the arm. The distal end, or the insertion of the bicep, as we get to a point, you can see it actually starts to go right into the bone. So let's see if somehow we can get some things solved. The other problem we have is we have primary motion. We have the primary motion where the muscle moves with the humerus, but we have no secondary motion. Somehow this bicep should change its mass as it's contracting to make the forearm flex, right? So if it's getting shorter, if this distance between the origin and the insertion is getting shorter, then the muscle mass has to react. It has to stay the same, the mass, but it has to change to suggest that shortening. So what we're doing the next tape is actually make that that distortion occur, or metamorphosis occur.